Hello, this is Mr. Ferris. This video is going to be over the Finite Math Lesson 14.3, which develops a new method of apportionment that we have not learned yet. We've learned some of the basic principles, and we've learned of the Hamilton method. But now we're going to turn to another idea of how to do apportionment. I will let you answer number 1 and number 2. You can get those out of your textbook. I want to jump in and talk about another guy's method, and I've been alluding to this in class. Thomas Jefferson had a way of doing apportionment that's a little bit different than Hamilton. It's much more complicated. That's why I'm doing the video, so you can stop and rewind and listen to things again if they went by a little fast. So Thomas Jefferson came up with another method of doing apportionment. But let's review just a couple things. First of all, we typically always want to calculate the standard divisor when we're doing any apportionment algorithm. So the standard divisor, you might remember, is calculated by taking the total population. In this case, it would be the total population of the United States. And we divide by the number of seats in the House. We'll just call that the House size. So, for instance, back in 1790, the very first census, the United States had 3,615,920 people. To get the standard divisor, we divided by the house size. Back in that day, the house size was 105 seats, and we got a standard divisor of 34,437. That is the standard divisor. But another way of looking at it, yes, that's the standard divisor, but let's think about how that was calculated. We took the total number of people and we divided by the number of seats in the House of Representatives. So you could say, and I think we labeled this already, this is the number of people per seat in the House of Representatives. Or another way of saying it is, this is the average. I'm going to abbreviate to go faster. This is the average district population. So on average, every district, every House district in the United States had about 34,000 people in it. So this was the kind of the average district population. So back in 1790, each member of the House of Representatives represented about 34,000 people on average. That's the average district population. But again, let's review, because Thomas Jefferson had an interesting idea. Thomas Jefferson said, all right, Hamilton used a standard divisor of 34,437. Thomas Jefferson said, let's use a standard divisor of 33,000. Now, why would he do that? Well, there's a very good reason. I'll show you the arithmetic behind it. The way we did it before, we divided by 34,437, and this is what happened. When we did that in the Hamilton method, I haven't shown you this program yet, but we did this on paper. Here's the 34,437 standard divisor up here in the top right corner. And I gave you a spreadsheet very similar to this. You had Virginia as the biggest state all the way down to Delaware. If you add up this column that's in blue here, you would get that 3,615,000 number. And then you might remember we kind of divided up the work, and we divided every state's population by this 34,437, and we got the quotas. That would be these numbers under the word quota here. So Virginia's quota was 18.31, Massachusetts was 13.8, et cetera, et cetera. And then the rule for Hamilton was you round all of these down. And so that would be 18, 13, 12, 10, 9, 8, all the way down to 1, 1, 1. And you might remember that when you added up all of these rounded down numbers, you got 97. The problem is there's 105 seats, so we're 8 short. And you might remember with the Hamilton method, when you're short 8 seats, you give those 8 seats to the 8 states that had the highest decimal value. So certainly the 0.995, 988, 989, 803, a lot of those were the ones that got the extra seats. That was the Hamilton method, rounding by taking the highest decimals, and so the 8 states that had the highest decimals got those extra 8 seats, and that was the apportionment. But as we know, George Washington vetoed that, and so that didn't fly, and that was not the way they did the first apportionment. Thomas Jefferson came up with a different idea. His idea was change the standard divisor. And as I mentioned earlier, we wrote this down in our notes. Thomas Jefferson said, let's use 33,000 instead of 34,437. Now let's just think just for a second here. Before I show you what's going to happen, see if you can predict. When we use 34,000, we got these numbers under the quota column, 18.3, 13.8, 12.57. What's going to happen when you divide all the populations by a smaller divisor? When you divide by a number that is smaller, shouldn't you get a bigger quota? So that's what's going to happen. When I click enter, under the new quota column, you're going to see the new quota, and if arithmetic works the way we think it does, when we divide a population by a smaller divisor, we should get a bigger quota. So I'm going to hit enter. Focus your attention on the new quota column, and you should see these numbers bump up just a little bit. There they are. And so Jefferson proposed that when you use 33,000, the quotas are just a little bit bigger all the way down. And now if you round down, 19, 14, 13, 10, 10, 8, 7. Now when you round down, look what the total is. It's exactly the number that we needed. And look who got an extra seat that didn't get one under the Hamilton method. Virginia got an extra seat. They've got 19. Massachusetts earned another seat. They're 14. Pennsylvania earned another seat. They're up to 13. So the biggest 3 states all got an extra seat. And down here at the very bottom, Delaware did not get an extra seat. With the Hamilton method, Delaware got 2. So you can see, at least from one example, that this method that Jefferson proposed is a method that tends to benefit larger states. And so what he is doing is saying, okay, if we don't have enough under the Hamilton method when you round down, the best way to fix that problem is to change your standard divisor. And you make it smaller. And you make it smaller until you get up to 105. Now, I could go back. Let me go back to that 34,000 number real quick and just show you this in increments. I could have done this more gradually. Now, Jefferson probably did a lot of calculating and knew that 33,000 was going to be small enough. But what I can do, because I've got some modern technology, is I can drag this slider and I can make this number go down bit by bit by bit by bit, and you can watch this grow one at a time. And eventually then we're going to get up to, there we are, 99 already, 100, 101, 102, 100, takes a while to get to 103, 104, 105. So actually, Jefferson could have used 33,153. He didn't have to go all the way down to 33,000, because even with a divisor that is just that number, we would have made 105. And so that's a methodology called the Jefferson apportionment method. What you do is you just change your standard divisor. Instead of using the one that you would normally use for Hamilton method, you make it smaller and smaller and smaller until you finally get the magic number. Now, how do we do that in a classroom in 2014? Are we going to keep guessing and then doing all these calculations, guess another number, do all these calculations, guess another number? Because you don't have this software that I do where you can just kind of slide it down and watch the numbers go up. So we're going to learn a technique by which you can figure out for sure which states are going to get the next seat. So to do that, though, let me just think this through. Let me go back and let's find out who got the very first seat. So if we go back to like 34,000, where it was 97, when it got to be 98, who was the state that got that first extra seat? Boom, right there. Can you tell which state was the one that just barely earned another seat? Well, if you go back to these new quotas, it's pretty easy to tell which one it was. If you go back to these new quotas, isn't it going to be the state that just barely got over the next number? Boom, there it is, South Carolina. South Carolina started out with an original quota of 5.989. But by the time we reduced our divisor down to 34,370, it was just enough to qualify them to earn their sixth, 6.00054. So the very first state to earn another seat was South Carolina. Now, the question I have for you is, how could we have predicted that South Carolina would have gotten the next seat? How did we know that they would be the first one to earn their next seat? And it's actually a fairly easy calculation when you think about it. And so let me ask you this. Can you tell me a way to figure out how big this divisor would have had to have been for South Carolina to earn their sixth? If you just think about the arithmetic, it's really not that hard, because think about where this 6.00054 comes from. It comes from taking their population and dividing by the standard divisor. So if the population divided by the standard divisor gives them 6, that's how you're going to be able to find it in reverse. In other words, take South Carolina's population, divide by the seat that they're going to earn, which is the sixth one, and that would help you figure out exactly what this number has to be. So I've got my calculator right here. Let me just do that. South Carolina's population is 206,236. If I divide by the number of seats that they're trying to earn, they've got 5.989 already, so they're trying to earn their sixth seat. If I take South Carolina's population and divide by 6, which is the number of seats they're trying to earn, I get 34,372. So let me just test that theory. If I go to 34,372 and hit enter, notice that would have been big enough. That would have been big enough for them to earn their sixth seat. So you can always figure out the divisor that's necessary for a state to earn their next seat by dividing their population by the number of seats they're trying to earn, which in this case would be 6. So let me give you another one. Let's do another one. What would this standard divisor up here have to be for Virginia to earn their 19th seat? Virginia would like to earn 19. They've only got 18.31. The way you figure that out is you take Virginia's population, which is 630,560, and you divide by the number of seats they're trying to earn, which is 19. If you divide by 19, you get 33,187. So let me change this to 33,187 and hit enter, and notice that was just enough to give Virginia their 19th seat. That just put them over 19 by a little bit. So you can always figure out what divisor is going to give a state the next seat by taking the state's population and dividing by the number that they're trying to earn. This has a special name. This is called the critical divisor. So if we go back to the worksheet, the Jefferson method, the way we are going to be doing it, since we don't have this fancy little slider software, we're going to have to calculate what's called the critical divisor. The critical divisor for each state is what I just demonstrated for you. This is going to produce a number that can be divided into the state's population to produce a number that's just over the borderline. It's kind of an odd way to say this. It's just over the borderline for earning another seat. It's a little difficult to write this in a stylus. Hopefully you can read that. So this is what I was just doing twice for you in 1790. But we could even bump it up to 2010. Indiana's population in 2010 was 6,501,582. The quota for 2010 was 9.147. So the critical divisor for Indiana would be to take the population of Indiana and divide by the number of seats they're trying to earn. They would like to earn 10. So Indiana would like to earn their 10th seat. And so when we divide that, I guess I can do that in my head because you just divide by 10. That'll be 650,1 158.2. That would be the Jefferson critical divisor for Indiana. So critical divisors can always be calculated by taking the state population. This is the formula I was doing a couple times. You take the state population and divide by what we're going to call n plus 1. N is going to be defined as the tentative apportionment. The tentative apportionment, you might remember, the tentative apportionment is what each state earns if you round down. So the tentative apportionment for Virginia would be 18. Tentative for Massachusetts is 13. Tentative for Pennsylvania is 12. So the tentative is always just the rounded down number. But the n minus 1 then is going to be the number they're trying to earn. So the n plus 1 would be 19, 14, 13, 11. So that's how the critical divisor works. All right, so if you look at the 1790 table, which was on the previous handout, but I think I copied it on the 4th page of this handout, you should see a place for you to calculate the critical divisor for every state. We can just do it for Virginia. That wouldn't be too hard. So if we wanted to calculate, you can turn to your kind of the 4th page, or you can write it here, whichever you want. But we're going to calculate the critical divisor for just 2 states. We're going to calculate it for Virginia, and we're going to calculate it for Delaware. So remember from the previous, we want to take the state's population. So for Virginia, it's going to be 630,000. I'll just write that down up here just to make it visible. 630,560. That's the state's population, and we divide by, according to the formula, n plus 1. N plus 1 is simply just the number of seats that they are trying to earn, which is 19. So if you type that into your calculator, 630,560 divided by 19, Virginia's critical divisor is 33,187.4, roughly. If you do the same thing for Delaware, Delaware has or had a population of 55,540. And we're going to divide Delaware's population by n plus 1. Delaware earned 1, but they'd like to earn 2. So their n plus 1 would be 2. So if you take 55,540 and divide by 2, you get 27,770. All right, so now, see if you can remember back to my little, well, I'll just pull it up here. Remember, we started way up here at like 34,000. When I start dragging this to the left, is it going to hit Virginia first, or is it going to hit Delaware first? Is that number right there going to hit Virginia first or Delaware first? Well, remember, Virginia, when it gets down to 33,187, Virginia will earn their extra seat. When it gets down to 27,770, that's when Delaware is going to get their seat. So you see, Virginia is going to get their extra seat way before Delaware gets their seat. When that slider gets down to 33,000, Virginia earns a seat. But it has to go all the way down to 27,700 before Delaware will earn their extra seat. And it's not even on the scale. In fact, we know that by the time it gets to 33, we'll have 105 seats given out. So Delaware is not going to get an extra seat, at least not this time around. So by calculating these critical divisors, you can kind of tell which states are going to get seats first. The higher critical divisors, this is what this is saying, the state with the largest critical divisor gets another seat. And if you keep going down, 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 that's how you end up giving out all these seats. So the 8 states then that had the highest critical divisors would be the 8 states that get the extra seat. So Jefferson's method is a little more complicated than Hamilton's method. You have to calculate all the critical divisors for all the states, and then the 8 highest critical divisors are going to be the states that get the extra seat. So it's a little a little work, but it's not as much work as if you had to do it, 20 or 30 times for every single state. That would be a lot of work. However, as you might expect, there is a drawback to this method, and the drawback to this method is that sometimes a state can get more than its upper quota. A state might get more than its upper quota. Here's what could happen. Let me just take Maryland, for example. Maryland earned 8.088 by just using the critical divisor, so they're either going to get 8 seats or they might get 9 seats. But here's the crazy thing. Using Jefferson's method, it's possible that Maryland could actually earn 2 extra seats. In other words, Maryland could get 10, possibly. It is possible sometimes for states to earn more than just the rounded up. They might earn 2 more than they currently would have earned. So that would be one of the downsides of the Jefferson method. And then the quota condition, and really I think all the rest of these things in here you can find in your textbook. So I'm not going to belabor this anymore, because the quota condition is, all of this stuff is written in your textbook, so you can find all of these answers in your textbook. And then one thing I will just throw out, the Webster method is a little bit more complicated even than the Jefferson method, because the Webster method says that you're going to round up on a quota whenever the fractional part is greater than 0.5. And you round down if the fractional part is less than 0.5. And actually, I believe that's greater than or equal to, now that I think about it. So the Webster method says you earn another seat as long as you're halfway there already. If you're halfway to the next seat, you automatically get rounded up. So if we just take a quick peek back to here, and let me go back to kind of the original 97 here. Go back to the original 97. Back to the original 97, that means that the initial allotment for Massachusetts, they would automatically earn 14. Webster says they've already earned their extra seat because their decimal is higher than 0.5. Pennsylvania is higher than 0.5, so they would automatically earn 13. Let's see, New York would earn an extra one. Connecticut would earn an extra one. South Carolina, any of these that have a decimal that's already bigger than 0.5 would earn an extra seat. So you can probably imagine what could happen. If a whole bunch of these got rounded up, it's possible that you would have 106, 107 seats given out. So the Webster method kind of has the other possibility, and that is that we gave away too many seats, and now we have to kind of work it backwards and figure out who do we take seats away from to get it back to 105. So we'll discuss the Webster method a little bit later when I'm back with you. So next time in class, we'll talk a little bit more about the Webster method, but hopefully this gave you enough for the Jefferson method that it makes a little more sense. So you'll have a homework assignment over this, and so it's a good idea to do that and make sure that you write down any questions that you have, and we'll try to address them when you come back in class. I'll see you then.